Hello dear friends, welcome to a lecture of solid geometry. We are studying the sphere. In this lecture we shall study plane section of a sphere. That means what is the intersection of a plane with a sphere, and also we shall see what is the intersection of two spheres, that we shall see. First we shall consider plane section of a sphere. The locus of points, the result is written here. The locus of points common to a sphere and a plane is a circle, and that is a plane section of a sphere is a circle. So we shall consider this figure. Suppose this is a sphere. We shall suppose this is a sphere, and now we want to take its section by a plane, and that plane can be considered or assumed like this. This is plane which cuts the sphere. So what is the section, that is the intersection of this sphere with this plane, that we want to find out. And we may see this will be a circle which lie like this, or that is a circle. So this will be a circle. That we have to imagine it. So a sphere is cut by this plane and we obtain a circle. So any section of sphere with a plane is a circle, that gives a circle here, and we can now consider this as the center of the sphere. Suppose O is the center of the sphere, this will be the center of the circle here, and we can draw perpendicular from center of the sphere to center of the circle. Let this point be N, and we take a point on the circle or on the plane also, that is common point. And now this for understanding I have drawn this figure, but actually the meaning is the sphere is there and that is cut by a plane, and we get a circle here. So now to obtain the result or to derive the result, what we shall consider is only this plane. We will not show in the figure. For this understanding I have shown this plane in the figure. Now that is the section here we have obtained. Now see, so this is the section obtained by the plane, and this is the center of the sphere. And now we can consider a point on the section, on this section here or anywhere here. This is the point, and join this to the plane, or I shall consider that point at this here itself. This is a point. It is a point on both the plane and the sphere, and we shall suppose that point as P. Now this is the center of the sphere, and this is perpendicular from center on the plane. Let O be the center of the sphere, and let ON be the perpendicular from O to the plane. N is the foot of the perpendicular. Further, let P be any point on this section. On the section means the plane. We are cutting the sphere by a plane, and P is a point on that. So P will be common point on the sphere and the plane. Now because ON, we have considered ON is perpendicular to the plane, and NP is a line in the plane. Since NP is a line in the plane, we have ON is perpendicular to NP. This ON is perpendicular to NP, and now we can join this O and P. See, this is joint. Now from figure ONP is right angle triangle, and therefore then we have OP square is equal to, by Pythagoras theorem, ON square plus NP square. And from this we can write NP square is equal to OP square minus ON square. So this is the result that we obtained. Now you see, O is the center of the sphere, so it is a fixed point, and N is foot of perpendicular, therefore it is also fixed. O and N are fixed, and therefore here this distance NP square depends only on the point P, or the position of the point P. Since O and N are fixed points. Why these are fixed point? Because O is the center of the sphere, it is fixed, and we have drawn perpendicular from O on the plane here. This is the plane we have to imagine, and that point is also fixed. It will not be different point, it is fixed point, only one point. O and N are only one points, and what changes is P, as the point P can be taken on in anywhere in this section, so it moves like this, and so therefore this NP square depends only on P. NP depends only on the position of P. And hence NP is constant. It is constant for all points P. P moves along this, and therefore NP is constant means it is the locus represents a circle, because N is the center and P moves with this distance, same distance around N, and therefore the section represents a circle, and hence therefore the plane section, therefore the locus of P is a circle. Locus means set of points which satisfies the given geometrical condition. What is the geometrical condition here is this distance remains fixed, because O and N are fixed, and therefore it is a fixed distance and the point moves with fixed distance, and therefore it represents a circle. Therefore the locus of P is a circle, and hence section of a sphere by a plane is a circle, or simply a plane section of a sphere is circle. So this proves the result, and thus we have seen that the intersection of sphere with a plane represents a circle. Now we shall consider intersection of two spheres. See, next part is intersection of two spheres. Let the two spheres be represented by, we will denote the first sphere as S1 and we will denote the second sphere as S2, and we write the equation of sphere in general form, and therefore the equation of S1 sphere will be x square plus y square plus z square plus 2u1x plus 2v1y plus 2w1z plus d1 is equal to 0. This is the equation of first sphere we have written. Similarly, we write the equation of the second sphere as in the same general form, x square plus y square plus z square. We change the parameters u, v, w and d as now u2, v2 etc. 2u2x plus 2v2y plus 2w2z plus d2 is equal to 0. Suppose this as 1 and 2. These are two spheres. Now what we should consider is then the difference of these two, S1 minus S2. Then or if we consider we want to find the intersection of two spheres, and therefore we want to find the common points on the two spheres if they intersect. They intersect means we have to imagine this type of situation. They are intersecting, the two spheres are intersecting, and now we are going to show that their intersection is this circle. The intersection of two spheres is a circle that we will show. Then the points common on sphere 1 and 2. Then the points common on spheres 1 and 2 are also the points on the we have to consider the difference of these two, S1 minus S2, are also the points on S1 minus S2, because these points, common point means this satisfies the first equation, that satisfies the second equation, and that means S1 is equal to 0, S2 is equal to 0 are satisfied. Then what we will get, S1 minus S2 is also equal to 0. So therefore S1 minus S2 is, what will be S1 minus S2? These three terms, first three cancels in the difference, and next we will have 2u1x minus 2u2x, x is common, 2 is common. So I can write this equation as 2u1 minus u2 times x plus 2, here also see the difference of these two, 2v1 minus v2 times y, and plus 2 w1 minus w2, 2w1 minus w2 times z, and plus d1 minus d2, and the right side is 0 minus 0 is 0. So this is the equation. Now we may suppose this as equation 3. Now what this equation represents, so the are also the points on this, and this is first degree equation. See, x, y, z and constant, and we know the first degree equation always represents a plane. So these are the also the points on S1 minus S2 which represents a plane. And thus the points common on the first and second sphere is also a point on this plane, and therefore the points common to sphere 1 and 2 now we are considering intersection of two spheres. Now the points common to both the spheres, both the two spheres are the points on any one of them and the plane 3. Now see what we have written is, we want to find intersection of two spheres, and therefore intersection means common point. The common point is the intersecting points, and therefore those points which are common to sphere 1 and 2 will also be points on this plane, because it is a difference of S1 and S2. So thus the common point of two spheres will be point on any one of sphere and the third equation, that is plane. So either 1 and 3. So points of intersection of two spheres S1 and S2 will be the points of intersection of, or points common to S1 is equal to 0 and S1 minus S2 is equal to 0. That means this is a sphere and this is a plane. Or the points common point of intersection of two spheres will be the points on S2 is equal to 0, second plane, second sphere and this plane. So either 1 and 3 or 2 and 3, that is points common to, and which are the points common to. So here what we have written, now the points common to both the two spheres are the points on any one of them and the plane 3, that is the points common to sphere 1 and plane 3, or sphere 2 and plane 3. But we know that either of this, sphere 1 and plane 3 or sphere 2 and plane 3, so they give the same points. And now, but the section of a sphere by plane is a circle, we have just proved it, which represents a circle. So therefore the points, the common points lie on a circle, and thus intersection of two spheres is a circle. So this is a result that we have proved, intersection of two spheres is a circle. So in this way we have taken two equations of sphere and their difference is a plane. So intersection of two spheres is either 1 and 3, common points of 1 and 3 or common points of 2 and 3. But in any case sphere and plane represents a circle, and therefore intersection of two spheres is a circle. So thus we have seen intersection of plane and a sphere and intersection of two spheres both represents a circle. Now we shall obtain equation of sphere in diameter form, or that is sphere with given diameter. With a given diameter. That is easy to derive equation of sphere, or to find equation of a sphere, equation of the sphere having the end points of a diameter. Diameter is given means its end points are given, having end points of diameter, or having the 2 points we should write A x1 y1 z1 and B x2 y2 z2 as the end points or extremities, end points of a diameter. So this we want to find equation of sphere. Now we can draw a figure for this, as the suppose this is a sphere and this will be the center of the sphere. Now let us suppose this is any diameter can be considered, but we can suppose this is the center and AB is a diameter. The coordinates of A are given as x1 y1 z1 are the coordinates of A, and coordinates of B are x2 y2 z2 that are given. Now what, to obtain equation of this sphere, we shall consider a point in this hemisphere, or see we shall take the section of this sphere by a plane passing through the center, and that will be these points, having that section will have these points A, B and P. So we will join AP and then PB also. So these two are joined, and now you see because this is a great circle, so one thing we have to note is a plane passing through the center of a sphere is called or that section gives a circle which is called great circle. So therefore this will be a great circle, or that means see, if we have this as a sphere and it's a section by a plane. So if you consider this as the plane, then the section is this circle. And if that plane passes through the center, this is the center of the sphere, that plane passes through the center, then a bigger circle is obtained, and that is known as great circle. Circle passing through the center is great circle. I should note that as a note. A section of sphere or a plane section of a sphere through its center is a great circle, is a circle which is known as great circle. So that we should note, and here what we have obtained is a great circle. So that is a sphere, and that is cut by a plane which passes through the center, and therefore it is a great circle. So that now we consider P is a point on this circle. So here we will assume P is a point and the coordinates are x, y, z. Let P x, y, z be a point on the sphere. Then this A, P, B are the points on the great circle. Then the points A, P, B are on a great circle. It is a section of the sphere passing through center, and therefore this angle APB is angle subtended in semicircle. Angle APB is an angle in the semicircle, and we know angle in semicircle is right angle. So therefore this angle is right angle, and therefore angle APB is a right angle, and that means AP is perpendicular. AP is perpendicular to PB. Now we will use the condition of perpendicularity. We will write the direction cosines of direction ratios, rather direction ratios of AP and PB. Now the direction ratios of AP and PB are, now see the direction ratios of AP, I shall write again here, are, we can write the ratios, direction ratios as the subtraction of the coordinates in any way, either x1 minus x or x minus x1. So we will write the direction ratios of AP and PB are, for AP x minus x1, y minus y1, z minus z1. You see the difference of these coordinates. And direction ratios of PB, we write x minus x2, y minus y2, and that is x minus x2, y minus y2, z minus z2 respectively. These are the direction ratios of AP and PB. And since AP is perpendicular to PB, we have by the condition of perpendicularity. If the two lines are perpendicular and we know their direction ratios, then the sum of the products of the direction ratios is 0. So therefore by condition of perpendicularity, we have now the sum of product of these direction ratios, that is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus, I shall write here, plus z minus z1 into z minus z2, and this is equal to 0. So this is the equation of the sphere in diameter form. That means if the diameters are given as a x1 y1 z1, b x2 y2 z2, then the equation of sphere is x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2, which is similar to the diameter form of circle. The diameter form of circle contains only these two terms, and that is equal to 0, x, y in terms of x and y. For sphere, we have one more coordinate, that is z, and this is the equation of sphere. Equation of the required sphere. That means sphere having extremities of diameter as a and b. So, and for an example, so it is easy to write equation of sphere. So find equation of sphere. Sphere having these points, say I can consider any points, say 3, 1, minus 2 and 4, 0, 5 as extremities of diameter. And it is direct, so by this equation we can write it as x minus x1. So its equation is, see, it will be x minus x1. What is x1? x1 here is, we can consider this as x1 y1 z1 and second point as x2 y2 z2, and therefore its equation is x minus 3, x minus, this is 3, x minus 3, x minus 4 plus y minus 1 into y minus 0 and plus z minus minus 2, that is z plus 2 into z minus 5 is equal to 0. So after simplifying, this equation can be put in general form, that is x square plus y square plus z square, etc. So in this way we can write equation of sphere with given points, 2 points as extremities of its diameter. So this is about a plane section of sphere, then intersection of two sphere and equation of sphere with a given diameter. Thank you for watching the lecture.